Welcome to Kadena's demonstration of our permissioned scalable blockchain platform. In this video, we are going to demonstrate the capabilities of the Kadena permissioned blockchain platform through an example application that we have built in the financial services domain. This concerns large-scale commercial lending in the form of syndicate lending, which are loans underwritten by a number of investors within a syndicate. Commercial lending represents an area where blockchain can make a significant impact, as the processing regime behind loan settlements is notoriously anachronistic, with agent banks often ferrying faxes and emails between buyers and sellers to close loan trades. And these inefficiencies have a direct impact on the profitability of financial institutions by tying up their balance sheet. With loan settlement times taking an average of 12 days and as much as 20, and with over $2 trillion of loans being made in this market every year, settlement delays, caused in part by these inefficiencies, are leading to at least $7 billion of capital being needed to be held against loan exposures on balance sheets of participating institutions. We will step through a number of aspects of the loan lifecycle, explaining key business processes, their associated pain points today, and how blockchain technology can solve many of these challenges. These lifecycle aspects will include creation of the loan record, assigning investors to the loan to fund it, selling a loan, managing the loan amendment voting process, as well as how an agent is able to see the full history of the loan lifecycle through the chain of ownership. We will see how blockchain across these process areas has the potential to reduce operational costs by as much as 50% and shrink the settlement process, which will free balance sheets and grow profitability. Initially, we will look at creating a new credit facility. In this case, we have chosen a large Fortune 500 pharmaceutical organization, Amgen, who has made a request to the agent bank for a B-type term loan facility of $10 million for working capital purposes. A B-type loan is an institutional term loan carved out for non-bank institutional investors. The loan is priced at 3% above London interbank rate. Prior to this step, the agent has sought bids in the market to be able to price the loan at an appropriate interest rate. In this example, Amgen has determined that it will pay back installments of the loan in 30 monthly installments. The blockchain immediately creates a digital payment schedule, which automatically creates workflow that will enable payment reminders. Because Kadena has enterprise integration capabilities, it can also create receivable entries in accounting systems and update customer records of both the borrower and agent bank system. Once the loan has been registered in the system, the agent can then allocate components of the loan to each loan syndicate member. In this case, the agent is selecting a large non-banking institutional investor that will fund a $5 million tranche. The details of the loan specific to the investor's tranche is negotiated between the investor and agent, and the agent uploads a signed loan agreement between the investor and the agent. This is attached to the loan. Blockchain's use of roles and rights means it's possible to store all information about a loan together, but restrict which roles can see what based on permissions. Furthermore, with the blockchain, the agent, as a super user, can see all documents across all investors and borrowers. The blockchain smart contract provides a level of automated workflow which can address tasks usually performed by the middle office operations team. This includes ensuring that an investor has passed necessary KYC checks and that the investor is entitled to participate in the lending and not barred based on any restrictions in the covenants in the loan agreement. The smart contract will notify relevant parties and update systems of the investor and agent, such as finance and accounting, customer records, and collateral management systems. Using blockchain for loan setup and allocation to investors is more efficient than traditional approaches for a number of reasons. Firstly, all documents are digitized. This digitizing of documents removes the need for faxing documents, and all parties can be certain that they are working off the same version of the loan agreement. Secondly, the loan agreement can be turned from a physical document into a computer program or smart contract that will run between the agent, investor, and the borrower, automating aspects of the loan servicing that are traditionally performed by humans. For example, one aspect of automation that occurs at loan origination is the automatic creation of a digital payment calendar for loan coupon payments from the borrower to investors. This is automatically created when the loan is set up, and the routing of payments can be automated once the loan has been allocated or sold to investors. This can radically improve payment settlement processes and remove the need for payment reconciliation. Each sale potentially involves changes to loan covenants. A seller may decide, for example, to sell the loan but retain voting rights. Today, this information is stored in a physical paper loan agreement, which must be reviewed individually to determine how a new transaction agreement varies from its original. With blockchain, changes in loan terms such as covenants can be automatically tracked by a computer rather than a loan operations team needing to compare physical documents themselves. Another key area that tends to introduce delay in the settlement process of a sale involves borrower consent. The borrower is a final arbiter of whether a loan can be sold to an investor. A borrower may reject a sale because they are concerned that an investor may be a competitor and therefore could be privy to non-public commercially sensitive information that exists in the loan documentation. However, obtaining borrower consent can introduce delays because this consent process today is a manual telephone and fax-based process. With blockchain, the borrower consent workflow can be automated and digitized. Blockchain enables borrower consent to be provided through a simple workflow, with the borrowers providing an immutable, verifiable digital signature that proves that they have agreed to the sale. The business logic in the smart contract can also automatically check for aspects, such as whether the loan covenants exclude a certain investor from purchasing a loan because they are competitors, again expediting the sales process. These are just some of the examples of how the loan transaction process can be automated through blockchain. In this case, Western Asset Management has sought to sell $5 million of its $10 million allocation to AIG. The sale is at full face value of the loan as opposed to being sold at a discount. Borrowers have the right to request for a change to terms of their loan, such as interest rates and repayment schedules. Typically, this is in response to a change in market conditions. Today, this process is facilitated by an agent, with each of the syndicate members voting on whether to accept or reject an amendment request. This can be a highly manual exercise, with agents calling investors, collating their votes manually, and then relaying back the decision to the borrower. In the case here, Amgen is requesting a change from 300 basis points over LIBOR to 4 basis points. With blockchain, investors are able to place a vote electronically. The blockchain ensures that there is an immutable record of what each investor has voted. Furthermore, because each investor signs their vote with a unique secret key, the agent can be sure that each vote is cast by only the entity that is entitled to do so. In this case, Western Asset Capital Management has decided to approve the vote. The rules around how many votes are required to carry an amendment is stipulated by the borrower and tends to vary between individual loan facilities. Some may require a simple majority, whereas others may stipulate a 2/3 majority, for example. These rules are typically defined in the loan agreement. Today, the process of confirming whether a vote has met the majority threshold tends to be a manual activity. This involves an agent chasing investors to vote, counting the votes, then reading through the documentation for that specific loan to determine if the vote has sufficient majority to have passed, and then finally manually updating records across various systems. However, with blockchain, as voting rules are digitized, the loan smart contract can automatically trigger when a voting threshold has been reached, notify participants, and update the various loan records and payment schedules without the agent needing to be involved. In adverse market conditions, investors will seek to reduce their exposure by partially or fully selling loan commitments that they hold. This can cause a challenge for an agent that may have to deal with an increasingly large number of transactions that need to be managed through to closure, as well as needing to track increasingly fragmented loan inventories. Understanding who owns what and keeping on top of closing transactions can become hard, and errors and delays can result. A key property of blockchain that improves an agent's ability to stay on top of the changing landscape is the concept of provenance, which is the ability to track an asset over time and as it changes hands and ownership. In this instance, we are looking at a loan facility of $20 million for AT&T, of which $10 million was initially funded by Western Asset Capital Management. Following an approved vote to lower the interest rate, the investor then sold off half their exposure to Kadena fund investments, which then sold the obligation to AIG, BlackRock, and JP Morgan. Because all information is digitized on the blockchain, the agent can fully interrogate each transaction, reviewing how loan agreements and covenants changed in time. Digitization means that rather than having to perform a compare and stare to determine changes, the system can automatically flag changes to aspects such as covenants as the loan was traded. In our next video, we will turn our attention towards the technical aspects of the solution, looking underneath the hood to look at the underlying smart contracts that enable the blockchain to work, and how the blockchain uses aspects such as cryptographic keys to ensure that the history of transactions is tamper-proof. If you are interested in learning more about the Kadena platform, a free evaluation version of our platform is available on AWS Marketplace today. Smart contract samples that include the commercial lending examples here are available at kadena.io/try-pact. You can also visit kadena.io to learn more, or email info@kadena.io to speak with a Kadena representative.